Welcome to another episode of ProSoft Technology Video Training. Today we're looking at the PLX51 PBM gateway configured as a master on a PROFIBUS network, allowing a PROFIBUS slave device to communicate with a compact logic processor on EtherNet IP. The master setup is only available for the PLX51 PBM module, while the slave configuration is available for both the PLX51 PBM in multi-slave mode and the PLX51 PBS. So we'll be setting up a PROFIBUS DP slave, such as a Siemens ET200IO or some other type of transmitter on PROFIBUS DP. And on the Ethernet side, we'll have a ControlLogix or Compact Logix processor. And our PLX51 gateway will act as the PROFIBUS master communicating with the slave. So we'll cover downloading and installing PROFIBUS PLX50 configuration utility software, creating a new project for our gateway, configuring the PLX51 for both the PROFIBUS and EIP networks, uploading the PLX51 ADS file from the gateway in RS links, importing the slave device GSD file and updating the GSD catalog, and finally we'll look at some features including PROFIBUS DP packet capture. The first thing that we need to do is download and install the ProSoft PLX50 configuration utility software from the ProSoft Technology website. This is a free application that is used to configure the PLX51 PBM gateway, and it will allow you to do all the necessary configurations and mapping to make the module an integral and useful part of your program. So once we have all the files downloaded, install the PLX50 configuration utility to your PC by following the prompts. When it's done, we'll open up the configuration utility and open a new project. The first time you connect the PLX51 to your network, you'll need to launch the DHCP server and assign it an IP address on your subnet. It's this button here in the menu bar, and there is our gateway. You can click Assign, and on the window that opens, I'll enter the IP address that I know is available on the local network. I'll check the box for a static address and click OK. The bar should turn green, and this lets you know that the gateway is now connected, and we can close this window. Next, right-click on the New Project under the Project Explorer and select Add. On the Add New Device window, select the PLX51 PBM and click OK. We then come to the main configuration window. You can see we have 6 tabs at the top. The General, PROFIBUS, and Logic tabs encompass the basic configuration for the gateway, and the Modbus tabs will only be enabled if that mode is selected. And at the time of this recording, it's not been released yet. On the General tab, you give the gateway an instance name and a description as well, if you like. Now, the instance name should match the name that you use in your RSLogix I/O configuration. It doesn't actually need to match in order to work, but it simplifies things if it does. Just keep that in mind. You then enter the IP address. You can click the Browse button to the right of the address field to bring up the target browser, where you can see all the PLX50 gateways on your network. So select your PBM module. It will have the IP address that you just assigned. Click OK, and the IP will appear in the address field. Then we come to the operating mode selector, where we have 3 modes to choose from. You can choose to have it in slave, master, or quiet mode, where it will just monitor traffic on the network. I'll set my gateway to standalone master mode. We'll move on to the PROFIBUS tab, and as you would expect, this is where you configure your PROFIBUS master parameters. We have several sections for basic settings, advanced settings, error management, and a lot of timing options. You will set the station address, the highest address that you want to scan to, and the baud rate to match the PROFIBUS devices you'll be connecting to. For timing, Generally, the auto recommend function will do a good job of adjusting the PROFIBUS timing parameters to suit your settings. And note that anytime the baud rate is changed, you'll need to click the apply button before the timing can be recalculated. And on the Logics tab, we can configure the connection to a Logics processor. The EtherNet IP connections count depends on how much I/O you'll be connecting to. One EIP connection should be good for several hundred bytes of data. And you can have up to 4 connections. Now I'll leave it at 1 for this training, and I'll click the Browse button to locate my controller. And once I found it, I'll click OK, and it will appear in the controller path field. Under the Advanced tab, we can enable device level ring and set our connection to an NTP server. If you plan on connecting to devices on a DLR, you should enable DLR here in order to make use of the redundancy features. And for your information, if you don't use DLR, then the 2 ports on the module can act as a 2-port switch. As for the NTP feature, I just have my own PC set up to act as an NTP, so I'll enter my computer's IP address. So we've set up our PLX51, and we can begin adding PROFIBUS devices. To do this, right-click on the PROFIBUS devices tree item under the PLX51 module and select Add PROFIBUS device. We'll use the GSD file selector to find and select the required GSD file for our slave device. Now, if you need to bring in your slave device GSDs, you can do so in the GSD file management under Tools. So just go up to GSD file and choose Add to bring in new GSDs. Now, once you've imported a GSD into the configuration utility, it will always be available. You can also import an entire catalog by using the export and import options under catalog. So back under Add PROFIBUS device, just pick your slave GSD and click OK. This brings up the device configuration window. Now in the General tab, you should enter an appropriate instance name. The name will be used in the generation of the device-specific DDTs. So be sure to use a name without spaces or illegal characters. I know this device will be at node address 3 on the network, so for clarity, I'll add an _3 at the end. On the PROFIBUS configuration tab, we'll set the node address that the device is using, as well as the other PROFIBUS parameters. The user parameters tab is used to modify any of the external user's parameters. The content that you see on this tab will be dependent on the selected GSD file. Next, we'll go to the slot configuration tab, and here I can configure the slots of the hardware that I'm connecting to. We'll click Add Module, and in the window that pops up, we can go down the list and select the appropriate modules for the device. For this demonstration, I'm using a Siemens ET200, so I'll need to add configurations for slot 1, 2, and 3 first, and then I can add the input and output modules. Again, this will just depend on your specific device. And when we're done, we'll click Apply and then OK. If we have additional different PROFIBUS devices to add, we can go through the Add Device process again for each of those. However, if we have 2 or more slaves, just like this one that we want to add, then we can simply copy this slave, right-click, and select Paste Special. In the window, I'll delete the 3 at the end of the device name, and I'll set the paste count to 2. Set the starting address location to 4, and I'll also check to add a suffix with the station address into the device name. The Use Default Config option will, if checked, create a new instance based on the GSD file defaults. Otherwise, it will copy the settings from the configured instance that we're copying from. Click Paste, and 2 additional devices with the same configuration as our first device will appear in our Explorer. This is an easy way to add many instances of the same sort of device to your project, and everything will be sorted and offset appropriately. I don't actually have 2 additional devices to connect, so I'll get rid of these. And now is probably a good time to save the project. Once the PLX51 and its Profibus slave devices have been configured, the ladder file can be exported for later import into Studio 5000. So just right-click on the PBM module and select Generate Logix L5X. In the Export Options window, we'll select the destination where the ladder file will go and click Save. And just FYI, this is going to be a routine file, not a rung file. Next, we can open RSLinx Classic and upload the EDS file from the gateway. Just locate the unknown device with our PLX51's IP address, right-click and select Upload File from Device. We'll go through the prompts to download and install the file, and this will give us an AOP that we can use to make the EIP side of the gateway recognizable to our Logix program. And as you can see, it now has its own little icon. Now moving on to Studio 5000, I already have a new project set up and ready to go. I'll begin here by adding the PBM module to the existing project. Under the Ethernet connections of my backplane, I'll right-click and add a new module. In the Select Module window, I'll type PBM to filter the results. And once you've found the PLX51 PBM, select it and click Create. And this AOP will only work for Logix version 21 or higher, for your information. In the new module window, give the module a name and enter the IP address that you assigned back in the configuration utility. Click Change under Module Properties, and here is where you set up the I/O connections. Now, I only have 1 connection for this training, so I don't have to do anything. But if you have 2 or more, you'll need to be sure to add them in here. Now we'll bring in the ladder file that we exported. So under Main Task, we'll go to Main Program and right-click and choose Import Routine. Choose the L5X file that we exported and click Import. In the Import window, you can see the tags that the routine is bringing in. Note that the name for the input and output under Final Name needs to match the name that we gave the PLX51 PBM under the General tab back in the Configuration utility. Now, I just gave it the name that I knew would be generated here. Otherwise, you can edit the names here to match what you entered in the Config utility. Just know that if they don't match, you'll see an error here. So now we can open up the main routine and bring in a jump to subroutine. And with the routine name being our PLX51 PBM map, I'll verify just to be sure that no silly mistakes have been made so far. And if all goes well, I can then go up to Communications and select Download. The PLC will receive the new configuration, and when it's done, we'll go online. Now, to activate the gateway, we'll need to open up the controller tags, expand PBM Master Control, and under Master Control, enter a value of 3. This sets the module's Profibus state to online. So now, if I go back to the configuration utility, we can download the configuration to the module, and this will also take our project online. And I can see that my slave device is now showing up green in the Project Explorer view. So everything should be connected and communicating at this point. Back in the Logix tags, you can see an entry for the PLX51 PBM PBD Slave 3 input and output. Now, PBD Slave 3 is the name that I gave to the slave device in ProSoft Configuration Utility. The input tags here will represent data that the Profibus master port on our gateway receives from the Profibus slave devices, and the output tags will represent data that our Profibus master is writing to those devices. If we return to the configuration utility, the PBM status form displays a number of communication and technical statistics. Under General Statistics, we can see how many packets are being exchanged, for instance. There's also a live list. If you were to plug in a new PROFIBUS device, it would appear here. We can discover new devices in the Discovered Nodes tab and add them online by just right-clicking on them and selecting Add Device. The PROFIBUS slave device's status can also be monitored by right-clicking on the device and selecting the Status menu item. This is very handy if you're troubleshooting a device that is not appearing on the network. You can open this up and see if it's online. Is it exchanging data? Is it enabled in the PLC program? Along with several other flags that alert you to specific problems. Also, if we right-click on the PLX51 in the project tree view, we can select the DP Packet Capture utility. This opens up the packet capture window, and the PLX51 will automatically start capturing all PROFIBUS packets, and will continue doing so until you press the stop button, or once it's captured 10,000 packets. And once the capture process has stopped, the data is presented in a table like this. The packets are displayed in the order that they were captured. You have the time here in microseconds, the direction, either transmit or receive, the packet status, the source and destination of the packet, the function, and finally the raw data over on the right side here. And you can save these captures by clicking the disk icon up in the toolbar. That's about it for this training. If you have any questions or would like more information about the PLX51 PBM, use the link in the description to go to its product page, or feel free to give us a call. And if you found this video helpful, please give it a like. And if you're interested in more training and educational videos about industrial communication technology and gear, subscribe to our channel. Until next time, happy training.